Hello, myself Vinay Kumar Sahu. I am a part of the group J051. Our topics for this assignment are polars. Polars is a powerful and high performance data frame library which is available for both the Rust and Python. Polar actually is designed to provide a faster and more efficient alternative uh, to traditional data frame libraries that exist like Pandas as well. It leverages Rust speed for computations and combines it with a clean and intuitive API for Python. This makes Polar better than Pandas. Polars help us in working with large datasets with optimized performances. These are the various key features that Polars offer. The first one being heterogeneous column handling. Polars efficiently manages mixed data types within the same data frame, ensuring smooth operations without performance losses, making it ideal for the real-world datasets with numeric, string, and categorical data as well. The second feature is memory efficiency. Polars use columnar storage to load only necessary data into memory, reducing footprints. It's perfect for the environments with limited memory, such as the cloud-based applications. The one more key feature is that it offers SQL-like querying. Polars offer an intuitive SQL-like API for efficient data manipulation, allowing users to filter, group, join, and aggregate data with simple syntax, reducing the need for the complex codes. Also, there is a one feature that's lazy execution. Polars build a query plan and execute it only when it's necessary. Thereby, it reduces unnecessary computations and optimizing performances, especially for the large datasets, making it more efficient than eager execution libraries like Pandas. And one very important feature is that it is very fast in comparison to Pandas. Polars is very faster than Pandas because it leverages Rust performance, memory safety, and multi-threading capabilities. Unlike Pandas, which runs on a single thread, Polars processes data in parallel across multiple cores, optimizing both speed and resource usage. Additionally, Polars use lazy execution, deferring computation until necessary, which reduces unnecessary work and improves the performance, especially for large data sets.
Demonstrating the main features of Polars. Performance and ease of use. Polars combine Rust's performance with Python's simplicity. It allows you to create data frames and perform efficient operations like filtering. For instance, we can easily filter a data frame based on age and get instant results. Handling heterogeneous data. Polars excel at working with different data types. You can effortlessly cast columns to different data types, like converting salary from float to integer or from integer to float, like given in the example, with a function called .cast. Memory efficiency. When dealing with large data sets, Polars automatically optimizes memory usage. We demonstrated this by creating data frame with a million rows, and Polars handled it efficiently. Pandas like API. For those familiar with Pandas, Polars offers a similar API. Operations like selecting columns, and sort are similar to that of Pandas. Polars provide powerful built-in transformations. We showed examples of pivoting of a data frame and joining two data frames, which are common operations for data analysis. Then, lazy execution. One of the Polar standout feature is lazy execution. This allows you to chain multiple operations without immediate execution, optimizing the entire query before running it. We demonstrated this with a large dataset showing how lazy execution can significantly improve performance. We also printed the runtime in this case. We get it as 0.1674 seconds, which is too fast. Speed comparison with Pandas. Finally, we compared Polar's performance against Pandas using a dataset of 100 million rows. Polars completed the operation in about half the time that of Pandas, that is 16 seconds for Pandas and 8 seconds for Polars, showcasing its superior speed for big data tasks.
In conclusion, Polars is a high-performance data frame library that surpasses Pandas by leveraging Rust efficiency, multi-threading, and lazy execution. Its speed, scalability, and broad file format support makes it ideal for real-time analytics, machine learning, and large-scale data processing.